am going to explain probability tree diagrams in this video. Under this, two cases will be discussed. First one, with replacement. Suppose there is a box front of us and 10 balls are in it, 3 red and 7 blue. We are going to pick one ball from the box randomly and note down the color, put it back. Then we are going to pick again and note down the color. We do this only twice. How do we draw a tree diagram for this experiment? There are only two choices. First choice, how many outcomes? Two outcomes, red and blue. These lines are called branches. We write possible outcomes at the end of the branches and we write the probabilities along the branches. What is the probability of red? There are 3 balls out of 10, therefore 3 over 10. Then blue, 7 over 10. Add these two probabilities, 3 over 10 plus 7 over 10, 10 over 10, that is 1. Yes, it should be always 1. Then consider the second choice. What are the possible outcomes? We know that is red, blue, red, blue. Then what are the probabilities? Since they have the same number of balls, so same probabilities. Then we need to write the probabilities to complete the tree diagram. Think about this. First one, red and red. That means the probability red and red, the intersection. That is 9 over 100. Next one, red and blue. That means the first one red and the second one blue. Probability is 21 over 100. Similarly, we can complete these probabilities considering the outcomes. First outcomes and second outcome. Then you see the last one, blue and blue. That means first one blue and the second one blue. The probability is 49 over 100. So this is the complete Venn diagram for this example. Now add these probabilities, 9 over 100, 21 over 100, 21 over 100, 49 over 100. It is also 1. It should be always 1. Now let me explain these probabilities separately. First one, probability of red one. Red one means the first try. Probability of blue one. The probability of red 2 given that red one. Why? We already know we had red color ball at the first try. Knowing the outcome of the first try, we are going to the second try. Therefore, it becomes a condition. This one, probability of blue 2 given that red one. Similarly, probability of red 2 given blue 1 and probability of blue 2 given blue 1. Now let me explain the second case without replacement. We again pick one ball randomly and without putting this back, we are going to pick another one from the box. This is called without replacement. How do we draw a tree diagram for this? Let me consider first one. What are the outcomes? Red and blue. Probabilities 3 over 10 and 7 over 10. Then consider the second choice. Now you need to understand we have the same outcomes red, blue, but number of balls are not the same. Now think about first one. Let me write the probability for this red. So how it become 2? Because the first try we had red according to this and we had 3 red balls first. But when we are going to second try having red one in our hand, we know there are 2 red balls in the box and total 9. That's why 2 over 9. But when you go to the blue, we had 7 blue balls at the first time. Therefore, we have 7 blue balls at the second time as well. Now add these two probabilities, 2 over 9, 7 over 9. It is also 9 over 9, which is 1. Yes, it should be always 1. Similarly, go to the next one. You see, first we had blue one, Therefore, now in the box there are only 6 blue balls out of 9 and 3 red balls out of 9. Therefore, 3 over 9 and 6 over 9 add these two probabilities, so it is also 1. Yes. Then we need to write the and probabilities. First red and second red. Probability of red and red is 6 over 90. Similarly, we can write the probabilities of each case. You have to write these probabilities to complete the tree diagram. Now let me consider the last one. The first one blue and second one blue. That is the probability blue and blue. It is 42 over 90. To make sure, add these probabilities, 4 probabilities. It always should be 1.